Hi dear students, good evening all of you. Good evening, welcome to Geeta's classes. Are you able to hear me? Good evening all of you. Good evening all of you. Are you able to hear me? Good evening Uma Reddy, Ravi Teja, good evening Dinesh, good evening Kirtika. Good evening ma. Yes, okay, thank you. Thank you Dinesh, Uma, Kirtika, thank you ma. So today we are going to see the last class of unit 2, that is geometric distribution. Okay. So we'll do some more problems. Previous day's class we have done one problem we have left no. So we'll do some more problems in Poisson distribution and then we'll go to geometric distribution. Okay. Good evening Mani Shankar. Good evening. Thank you Raviteja, Kirtika. Okay, before that we'll see this one. Geometric distribution, shall we start or we'll do problems in Poisson first? Which one do you want? Good evening Bhavana. Shall we start geometric distribution first? The definition is it is a discrete distribution. Geometric distribution. Do you remember Poisson and binomial distribution and Poisson distribution we have seen? Now geometric distribution. These three distributions are discrete distributions. Binomial we have seen already, Poisson and geometric. These three are discrete distributions. PD sums first, huh? Okay. Okay, ma. Good evening, Varun. Okay. Okay then. Poisson distribution sums. Have you completed this? What is, can you tell me? Using recurrence formula, find the probabilities that x is equal to 0, 1, 2, 3, 4, 5 and if the mean of the Poisson distribution is 3. So what is mean actually? Lambda. Lambda is equal to, we know that mean of the Poisson distribution is lambda. So lambda is equal to 3 we know. Already we have done, I have given you clues. Have you completed this problem yesterday? The previous class, have you done this? Anyone? What is P of x? P of x is equal to, I have told you e power minus lambda, lambda per x by x factorial, where x can take the values from 0, 1, 2, 3, etc. up to infinity. Okay. Now, lambda is equal to 3. If you substitute, this is equal to, what is P of 0? What is P of 0? E power minus 3 into lambda per x. So, lambda per 0 or 3 per 0 divided by 0 factorial, that is e power minus 3. What is the value of e power minus 3? Fifth chapter is different compared to previous chapters. Which fifth chapter, fifth unit do you mean by fifth unit, Shivakumar? Fifth unit? No, I didn't get your doubt. Kirtika, I told you already how to find out this value. Shift and ln you have to. Okay, okay. You are from JNTU, right? Are you from JNTU? Yeah, I think the number shows that you are from JNTU only. JNTU, then there is no difference, no? Fifth chapter is stochastic process, right? Fifth unit is stochastic process. It is uploaded already in the channel, it is available. Stochastic process. Yes, ma, 0498 e power minus 3. Yes. Kirtika, be careful always. 0498. When you are writing 4 decimals, you have to round it from the 5th digit. Okay, that's why Manaswini has written 0.0498. That is correct. Okay, be careful always. 0.0498. Okay, now we have to find out P of 1. See, already we have found out P of x is equal to x plus 1 is lambda by x plus 1 into P of x. Right? P of x plus 1 is lambda by x plus 1 into P of x. Now, P of 1 if you want, lambda by whatever is there you write here. Lambda by 1 into e power, that is P of 0. P of 0. That is lambda is what? 3. 3 into 0 0.0498. Instead of 0498. Instead of substituting all these values and all, you can directly write in the recurrence formula. That's why it is written using recurrence formula. Find the probabilities when x is equal to 0, 1, 2, 3, 4 and 5. Okay. Yes. Yes, Shivakumar, it is not different actually. Of course, it does not depend on the previous chapters. Okay. It will be little different topic. Actually, it is an extension of our random variables only. But very interesting topic. It will be useful. Okay. Very useful topic. Lot of applications you have in the from the 5th unit. Very small unit only. So, here lambda of 2. What is P of x plus 1? According to the formula, P of x plus 1 is equal to lambda by x plus 1 into P of x. Right? So, lambda by x plus 1. Here 2. Lambda by 2 into P of 1. So, whatever value you are getting here, that should be written here. Yes. Okay. Okay, Shivakumar. And don't worry, you have time for your exam. Okay. To complete 5 units, you have enough time. Now 2.5 units only. You have to study only 2.5 units for your first mid. Okay. So lambda by 2 into P of 1. Yes, ma. So 0.0498 into 3 is 0.14936. Yes, ma. Very good. 0.1494 you can say. Yes, Ravi Teja is right. Yes. 0.1494. Now, P of 1. So, lambda is 3 by 2 into 0.1494. What is the value? 0.2241. 0.2241. We are in second unit ending. We are in second unit ending now. Okay, this is second unit, last topic of second unit. Discrete distributions. In discrete distributions, you have binomial Poisson and this one. Okay. 0.2241 is correct, Ravi Teja. Very good. Kirtika, you got a circular no from January. So depending on the college to college, it may vary. Generally, it is from 23rd according to JNTU. Maybe for you, it may get delayed. January first week, that's what I heard. Okay. Yeah, P of 2 is it not 0.2241? Uma Reddy, P of 2, 0.2241. No, Raviteja is right. I got into 3 divided by 2, ma. Into 3 divided by 2. Okay. So 0.1494. 0.1494 into 3 divided by 2. Yes. So 0.2241 is correct. Uma Reddy. Check the values once again. So again P of 3. What is P of 3? P of 4, P of 5. That's what is asked. Okay. So P of 3 is what? 3 by, here 3 is 3 into P of 2. So 3 will get cancelled. P of 2 is 0.2241. Dinesh Reddy, 0.224 is correct, ma? 0.2241. Very good. Uma, check the values. I hope you understood. And what is P of 4? P of 4 is 3 divided by whatever value you have, that you have to write in the denominator, that is 3 by 4 into P of 3. That is 0.2, 3 by 4 into 0.2241 into 3 divided by 4. What is the value? Quickly find out P of 4 and last is P of 5. P of 5 is 3 divided by 5 into P of 4. Tell me the values. P of 4. P of 4 and P of 5. Do it quickly. P of 3 value. Anyone? P of 3 is 3 by 4, 0.2241. P of 2 into 3 divided by 4. Into 3 divided by 4. So 0.2241 into 3 divided by 4. Values. All of you have calculator, I think. Okay. 0.1681. Very good. Excellent. Yes, ma. MS. Yeah, 0.1681. Very good. Yes, very good. Excellent, because fourth digit you have written, no, you have rounded from fifth digit. Yes, very good. That's what I want. Yes, ma. 0.1681. Always remember, when you are writing, how many ever digits you want, you can write, no problem. But please round it from the next digit. Okay. Yes. 0.1681. Yeah. Next is P of 5. P of 5 is 3 by 5 into P of 4, right? So 3 by 5 into 0.1681. Yes, very good. Excellent. 0.100. Now only I told you have to write from the, round it from the next digit number. So 0.1009. It should be 0.10, 0.10, 10086, right? So you have to round it from the next digit. So 1009. 1009. MS 0.1009. Okay, that is the value. So these are the values asked. So if you have this recurrence formula, using recurrence formula, it is very easy for us to find out the values. Okay, if you know the previous value, it is very easy. Otherwise, you have to substitute everything in this 3 power 1, 2, 3, 4 and all, you have to substitute. Okay. So P of 0, P of 1, P of 2 and P of 3, P of 4. This is P of 4, P of 3, P of 4 and P of 5. Okay. Yes. Next question. Any doubts in this? If you have any doubt, tell me. Otherwise, we'll go to the next question. A manufacturer, those who have completed, please go through this question. Yes, ma. Yes. A manufacturer knows that the condensers he makes contain an average 1% defective. He packs them in boxes of 100. What is the probability that a box picked at random will contain 3 or more faulty condenser? Always remember, when n is large and p is very small, then you have to go for Poisson distribution. Otherwise, you have to go for binomial. Okay. A manufacturer knows that the condensers he makes contain an average of 1% defectives. He packs them in boxes of 100. What is the probability that a box picked at random will contain 3 or more faulty condensers? What is given? First of all, given values you write. What is n value here? What is n? What is small p? Yes. N and P are given, then you can go for lambda. Okay. After finding N and P, you can go for lambda value. Therefore, lambda is equal to N into P. Directly you can write. N is equal to 100. Very good, Uma. Very good, Uma. N is equal to 100. Very good. Small p. N is equal to 100. Kirtika, very good. N is equal to 100. Correct. Very good. Super. P. What is the value of P? P. Always need not go for that success means, it the literal meaning you need not take. Okay. So here whatever is given, that can be taken as P. Average 1% they have given. Okay. So defective can be taken as P, small p, because the question also will contain 3 or more faulty condensers. So it will be easy even if you take defective as small p. Okay. So what is small p? Small p is 0001. Yes, 1%. 1% ma. 1%. Only 10 Uma Reddy. It is 1% means 1 by 100. Okay, so 0.01. Small p is 0.01 ma. 0.01. Okay. And what is our lambda now? We want lambda, right? See, if you are going to use binomial distribution, you want small p and q. N, p, q are needed. When you are using Poisson distribution, we want lambda, that is mean. Okay, mean. Okay. Uma, it is small p is 1% is given, no ma, so 1 by 100, so 0.01. Only 10. Yes, Kirtika, correct ma. Uma, 1% is given, no ma, therefore 1 by 100. Percentage means 1 by 100, right? So 0.01. So lambda is equal to N into P, that is 100 into 0.01. If you multiply again, you will be getting 1 only. 1. So lambda is equal to 1. This is what we found out. Therefore, P of x is equal to x is e power minus lambda into lambda power x by x factorial according to the formula. So e power minus 1 into 1 power x divided by x factorial, right? Now what is asked? Mean is 1. Yes ma, very good, very good. Dinesh Reddy, 1 minus p is q. How p is 1? It is given, no ma. See, an average contains an average 1%. See, in the place of p, you can find out it is 1 by 100, or from the name itself you can find out average is 1%. So directly lambda is equal to 1 also you can take, no problem. Lambda is equal to 1 also you can take. Because they have given, the packs them in boxes of 100, they have given, no. So n is 100, p is 1%. That is defective. See, a manufacturer knows that the condensers he makes contain an average 1% of defectives. Okay. Therefore, we are taking small p as 1%. It is need not be, the success means literal meaning, you need not connect it with. Always it is not non-defective to be taken success, nothing like that. Whatever is given you can take. Okay. Accordingly the question whatever is asked also it will change. Understood Shiva Kumar? That is why P is 1% is given. Okay. 1% is defective. 1% of that boxes. Okay. So 100. So 1% means 1 by 100. That is why it is 0.01. And each box contains 100. So N is equal to 100. NP. NP you have to get 1 because contain average 1% defectives. Okay. Formula is Poisson distribution. Because small p is very small, 0.01. N is 100. Therefore, we have taken Poisson distribution. Okay. When p is very small, you have to go for Poisson. Otherwise, you can go for binomial. Here we have p plus q is equal to 1. The same conditions apply. Okay. So here lambda is equal to 1. This formula is Poisson distribution. PMF of Poisson distribution. Okay. So this is now what is asked. What is the probability that a box picked at random will contain 3 or more faulty condenser? Therefore, P of x greater than 3. X greater than 3. That will be easy if you greater than 3 means what? It is 3 or more. So it should be included. X greater than 3 or more. So 3 should be included in that. So what is asked? P of x greater than or equal to 3. So that means what? P of 3 plus P of 4 plus P of 5 plus etc. plus P of 100. Because n is equal to 100, no. So instead of that, what you can do? What you can do now? 1 minus P of x strictly less than 3 you can take. Okay. So 1 minus P of x less than 3. X less than 3 means what? You have to consider P of 0 plus P of 1 plus P of 2. This is 1 minus of P of 0 plus P of 1 plus P of 2. If you want, you can write x is equal to 0, P of x equal to 0, P of x is equal to 1. So that it will be easy to substitute for you. X is equal to 3. So you have to substitute here. So 1 minus of, what is P of x is equal to 0, e power minus 1 is common, you can take it out or you write it e power minus 1 divided by 0 factorial plus e power minus 1 by 1 factorial plus e power minus 1 by 2 factorial. That is equal to 1 minus e power minus 1 of, it is Uma, 1% of the pack, okay, is defective. That is 1 out of 100 is defective. That is why P is taken as 1 by 100. And what is given? Contain an average. Average means 1%. That is why lambda is 1. Lambda is not 1. 1% of, because he packs them in boxes of 100. If he does not pack them in boxes of 100, you have to take this as P only, 1%. Okay. Anyway, 1% means you are not supposed to take 1. How can you take 1? Because it is 1%, no. That means 1% itself means what? 1 out of 100. 1 out of 100, that proportion. Okay. That is why P is equal, I have written here, you see. P is equal to 1% means 1 divided by 100. Okay. Average, if you take, it will be lambda. Directly you can write lambda is equal to 1 also. Because with the word average is given. And an average 1% defective. You can either take lambda is equal to 1 directly, or if because they pack them in boxes of 100, n is equal to 100 and P is equal to 1%. That is 1 out of 100 is defective. 1 out of 100 is defective. That is why we have taken 1% means 1 by 100. That is why P of small p is equal to 0.01. Got it, Uma? Got it, Uma? 0.01. Okay. Hope you understood. So here 1 minus e power minus 1 into, you can take this is 0 factorial is 1 plus 1 factorial is also 1 and 1 by 2 factorial is 2. Okay. So what is the value? You evaluate and tell me. Yes, understood. Yes, Umar. Good. 0.08, it is not ms 0.018. Yeah, ms is right. 0.0803 is correct. Very good. Very good. Kirtika, check the values. Maybe 1 minus. I don't think you will get that. Check the values once again, Kirtika. Always remember e power minus 1 in the calculator. You have to use this one only, ln. Here only you have e power x you will have. With that shift key, okay. Always remember you have to use ln only, not log. In the calculator in the right hand side you have e power ln. In this key only you will have ln. In this key you will have ln, so e power minus, okay. Sorry, e power x. E power x in the left corner with the yellow color. Not e power x, you have that square box. E power that square box. ms is correct. Very good. 0.0803 is correct. Yes, ma. 0.0803 is correct. Dinesh Reddy, 0.0803 is correct. Very good. Very good. MS and Dinesh, very good. Excellent. 0.0803 is right. 1 minus, no? Kirtika, do it again. Hope all of you are getting values. All the others. Have you got? Next problem, take a screenshot, ma. Otherwise, you can see later also. Take it as a homework. This is also using Poisson distribution only. A hospital switchboard receives an average of 4 emergency calls in a 10-minute interval. What is the probability that there are at most 2 emergency calls in a 10-minute? Please practice this problem. These kind of questions you can expect even in university exams. Okay. Yeah, Uma Reddy is correct. Kirtika, ma'am will take 1 minus p of x. Yes, ma. No, ma. P of Kirtika, it is greater than 3. See, will contain 3 or more faulty condenser. That's what they asked, Kirtika. Picked at random will contain 3 or more. They have given 3 or more. That is, P of x greater than or equal to 3 is asked, no, ma. So, 1 minus when you consider, it will be less than 3. Strictly less than 3. When you have greater than or equal to, 1 minus will be less than 3 only. Okay. Less than 3. Should not consider equal to 3. Equal to 3 will be included in this only. You cannot include in this. Understood? Got it? So this problem is Poisson distribution. Please do it as a homework. Practice this problem. This is already available in my channel. The same problem we have done already. This is for practice only. I am giving these problems again. Okay. So it is done. Please practice this problem. These kind of questions you can expect. Okay. Yes, ma. 0.0803 Shivakumar. No, 0.0803 only. Not 0.803. Check once again. Even I got. Yes, ma. Okay. Okay, Kirtika. You are welcome. Okay, next is geometric distribution. Quickly we'll go. So in discrete, we have seen binomial is over, Poisson is over. Next is geometric. Okay. In discrete, only 3 distributions are there for you in the syllabus. So third is geometric distribution. So in geometric distribution, what is geometric distribution? You have, because it is discrete distribution, you have PMF. Okay. Probability mass function. A random variable capital X is said to follow geometric distribution if it has the distribution small x is equal to P of capital X is equal to X is equal to, sometimes we write it as P of X is q power x minus 1 into p, where x can take the values 1, 2, 3, etc. and p plus q is equal to 1 as usual. Okay, and p plus q is equal to 1. See, remember, what is p? It is the success. If you consider again, p is success and q success of an outcome as usual. Q is the q is equal to 1 minus p. We consider this as failure. According to the question, you can take. And small x here is the number of trials. Number of trials. This is a little different from Poisson and binomial. So number of trials required to get the first success. Get a first success. Get a number of trials required to get a first success. That means if you are taking the first trial, you are not getting the required outcome, then it is said to be failure, right? And like that, first, second, third, etc. it is going on. Whenever you get first success, suppose if in the fifth task, if you are getting success, that means what? Previous q per x minus 1, that is, suppose if you have x is equal to 5 is the first success, then p is the success. Always p is the first success. Here remember, this is the first success. Or you can say previous to this one all are failures. That is, xth time you are getting success and previous x minus 1 trials are failures only. This is the first success. This is the keyword for using geometric distribution. Binomial, Poisson and geometric, we have one thing common, p plus q is equal to 1. That is only success. We have only two options. One is success and one is failure. If you have these two options, then only we say we will use this binomial, Poisson and geometric. Okay. In binomial, when n is small, n is normal value and q is normal value, that is not very small, okay, then we go for binomial. And if n is very large and p is very small, when n is large and p is very small, then we go for Poisson distribution. Then we go for Poisson, okay. And if pth success, that first success is p and before the first success all are failures, then if the question is like that, then we go for geometric distributions, okay. Otherwise, p represents the success, q represents the failure and p plus q is equal to 1. All these conditions are same for all the three discrete distributions, okay. So here you have to remember what is PMF of geometric distribution. P of x is equal to q per x minus 1 p, where x can take the values. That's why 0 will not be there. 0 means what? First trial itself is not there. At least one trial you have to do. Therefore, it is geometric distribution. X value is from 1. We are not considering. That means we are not conducting the experiment. 0 means what? X is equal to 0 means without conducting the experiments, how will you get the success or failure, right? Therefore, x is equal to 0 is not there at all. So, x varies from 1, 2, 3, etc. Okay, got it? Always first success is p. Before that, x minus 1, that is xth trial is success. And before that, x minus 1 trials are failures. Then you have to go for geometric distribution. Okay. So, now let us go for finding the mean and variance. These are very, very important. These derivations. Find the mean and variance of either binomial or Poisson or geometric you can expect. Okay. Find the mean and variance of. This you can expect definitely. So let us find out the mean of geometric distribution. So always remember mu is equal to E of x. Because it is discrete, we write from sigma x varies from 1 to infinity. X into p of x, right? Because you have E of x. So x into p of x. That is equal to sigma x varies from 1 to infinity. X into, what is p of x? Just now we have seen it is p into q power x minus 1 or q power x minus 1. That is x minus 1 failures and the first success is p. Now this p is independent of x, right? So I can take it outside. So p into sigma x varies from 1 to infinity. X into q power x minus 1. Substitute x is equal to 1. What will you get? That is small p into. Substitute x is equal to 1. You will be getting 1 into q power 0. That is 1 only. Okay. Plus 2 into x is equal to 2. This is for x is equal to 0. This q power 0 is 1. Therefore, I will write only 1. Okay. 1 plus 2 into q power 1. That is 2 minus 1. Or if you want, you can write one more step. No problem. 1 into q power 0 plus 2 into q power 2 minus 1 plus 3 into q power 3 minus 1 plus etc. Right? This is equal to small p into 1 plus 2q. Q power 2 minus 1 is q. Plus 3q squared plus 4q cube plus etc. The next term is 4 into q cube. What is this one? Small p into, what is this one? 1 plus 2x plus 3x squared plus 4x cube and so on. This is 1 minus q the whole power minus 2. This is the formula. These expansions you have to remember. This is minus 2. That means p by 1 minus q the whole square. What is 1 minus q? We know that p plus q is equal to 1. This is the relationship between p and q is p plus q is equal to 1. So what is q minus 1 minus q? 1 minus q is p, right? So this is p squared. And p squared, so 1 by p. So 1 by p is the mean of geometric distribution. Very simple, very easy. Very easy. The derivation is very easy. 1 by p. Go through this. If you have any doubt, you tell me. Otherwise, we'll go for finding the variance. Quickly. Any doubts? Just go through that and write. All of you, please write and practice. Write and practice. Any doubts? One by p is the mean of this. Always remember q power x minus 1 into p means xth trial is the success and x minus 1 are failures. That is up to the previous term it will be failure. Previous experiment it will be failure. And pth term, xth term is success. Xth trial will be success. Before that all are failures. Last line. Okay, ma. So here this is actually you have 1 plus x the whole or 1 minus x will write. These things, these series you have to remember, ma. 1 minus x the whole squared. 1 minus x the whole power minus 1 is 1 plus x squared plus etc. Okay. So 1 minus x the whole power minus 2 is 1 plus 2x plus 3x squared plus 4x cube and so on. Okay. This is the formula. This is the formula. Okay, 1 minus q. See, we know that in all the three distributions I have told you. One thing is common, p plus q is equal to 1. So, this is 1 minus q the whole power minus 2. This I am bringing it down. A power minus m can be written as 1 by a power m. Okay, that is why 1 minus q the whole power minus 2 is there. This 1 minus q I am bringing it down. That is 1 minus q the whole square. And we know that 1 minus q is nothing but p. So, p by p squared. It is 1 by p. Yes. Understood? Here minus 2 is by this definitions. Okay. This is the expansion of the series. The whole power minus 2. So, 1 minus q the whole power minus 2 can be brought down. So, p in by 1 minus q the whole square, p by 1 minus q is nothing but p. Therefore, I have written p square. So, p by p square will become 1 by p. Understood? Shall we go to variance? Any doubts? Got it, Shivakumar? I hope you got it. Yes? Any doubts? Any more doubts? Anyone? Shall we go to variance then? Variance. Yes, understood. Yes, ma. Okay. So what is variance now? According to the formula, variance of x is equal to, that is sigma squared is equal to E of x squared minus mu squared, right? What is E of x squared? This is equal to E of x squared is sigma, x varies from 1 to infinity. Let us find out E of x squared first, so that it will be easy for us. Okay. E of x squared is x squared into p of x. Whatever is here, you have to write. Okay, Shivakumar, welcome. So E of x squared is here, whatever you have, that you have to write here. So x squared into p of x. So sigma x varies from 1 to infinity. X squared into p of x is what? Q per, or p of x will write as it is. This x squared I am going to write it, I am going to add and subtract and add x squared minus x into p of x. P of x you write as it is, so that we will write later. So this is equal to sigma, and here this x squared minus x can be written as x into x minus 1. So sigma x varies from 1 to infinity. I am going to split it into two terms. This is x squared minus x and x term. Okay. So x into x minus 1 into p of x, one term, plus sigma x varies from 1 to infinity, x into p of x. Okay. What is this x into p of x? It is nothing but mu, mean, right? So now let us expand this. X is equal to 1. When you substitute x is equal to 1, this term will become 0, right? For x equal to 1, it will become 0. Plus, when x is equal to 2, what will happen? 2 into 2 minus 1. So 2 into 1 into p of x. Okay, p of x will write later. Sorry. P of x you can expand here. Okay. You write one more step. Or you can write q power x minus 1 into p. Okay, after that you expand. This can be written as x is equal to 1 to infinity. One more step I will write here so that it will be easy for you. X is equal to 1 to infinity. These two I am combining, x into x minus 1 into p of x plus sigma x varies from 1 to infinity, x into p of x. Okay. These two I am combining and this one separately. Understood? Yeah. So this is nothing but sigma x varies from 1 to infinity, x into p of x is nothing but mu. This is our mu. Okay. Mean. What is mean? 1 by p. You can write it as 1 by p. Just now we have found the mean to be 1 by p. Okay. Now you substitute this. X is equal to 0, everything will become 0. When you substitute x is equal to 1, everything will become 0. When x is equal to 2, 2 into 1 into q power 2 minus 1. 2 minus 1 is 1. Okay, into p, and p is common, so I can take this p outside because it is independent of x. So I am taking this p outside this sigma. Okay, so p is there common for all the terms. Okay, so plus when x is equal to 3, what will happen? 3 into 2 into q power 3 minus 1, that is q squared, right? Plus 4 into 3 into q power 3. I'll write one more term for our convenience. 5 into 4 into q power 4. Right? Plus etc. Plus 1 by p. That is equal to, this p is common. 2q is common. Right? Here 2q is there. Here also 2q is there. 2 into q is there. For in every term I have q, 2q. So that I am going to take it outside. So 2q into p into 2q into, what is there in the first term? 1. 2q, if you take it outside, then 3. What is remaining? 3q. 2 has come out. Okay. I have taken 2 outside. Remaining is 3 is there. And 1q has come out. Therefore, 1q I have taken outside. Remaining 1q is there. Next, plus. From this 4 can be written as 2 into 2. 1, 2 has come out. So remaining 1, 2 into 3. So 6 into 1 q has come out. So remaining is 6q squared. Plus 10 here 1, 2 has come out. Therefore here 2 into 2, 1, 2 I have taken outside. So 10 q per 3 plus etc. plus 1 by p. Okay. Again, this is again as it is an expansion. For this we have a formula. So 2pq is outside. 2pq into, what is this one? Anyone remembers this formula? 1 minus q the whole power minus 3. This is 1 minus q the whole power minus 3 plus 1 by p. Okay. So this is equal to 2pq into, what is 1 minus q the whole power minus 3? I can write it as 1 minus q the whole power 3 in the denominator plus 1 by p. Okay. What is this? All these things are e of x squared only. I have not even considered variance. Only first term e of x squared I have considered here. I have considered only e of x squared. But variance is e of x squared minus mu squared. Okay. So now this is equal to 1 minus q the whole cube can be written as 2pq into 1 by 1 minus q is nothing but p. So p cube plus 1 by p. So here 1p will get cancelled. This will become 2. So 2q by p squared plus 1 by p. Okay. This is our e of x squared. Therefore, variance of x is equal to what? E of x squared minus mu squared. Okay. So e of x squared minus mu squared. So 2q by p squared plus 1 by p minus p squared minus 1 by p squared. 1 by p is our mu, we know. Therefore, it is minus 1 by p squared. Yes. So you take LCM as p squared. You will be getting in the denominator, you will get p squared. And here you have 2q as it is, 2q and plus p, then minus 1. Right? This 2q I can write it as q plus p minus 1 divided by p squared, right? 2q I am writing it as q plus q. Q plus q is 2q. Okay. So 2q plus p minus 1. So this p plus q is 1 we know. So q plus 1 minus 1 by p squared. 1 and 1 will get cancelled. So q by p squared is our variance. Mean of geometric distribution is 1 by p and variance of geometric distribution is q by p squared. This is the formula. This is variance and mean is 1 by p. Any doubt in any step? Tell me, I'll explain. Just go through. Variance of x formula is e of x squared minus mu squared. Okay. And e of x squared is sigma x varies from 1 to infinity x squared into p of x. I am subtracting and adding x for my convenience and consider these two terms together. It will become x into x minus 1 and into p of x, and I am considering these terms separately, x separately and these two terms separately. Okay. So sigma x varies from x to 1 to infinity x into p of x. This is nothing but lambda, mu. Mu is 1 by p, that's why I have written 1 by p here, plus 1 by p. Just go through and please write in your paper. I believe in writing. When you write, then only it will practice. It will become a practice, and practice makes permanent. Otherwise, you write, it will be difficult for you. Now here I have substituted x is equal to 1, x is equal to 2, 3 and so on. Okay. And simplified. Any doubts in any step? Tell me. Otherwise, we'll go to problems. Any doubts? Any doubts? Please go through and tell me any step if I'll explain. Shall we go to problems then? Yes. Okay, we'll go to the first problem. Any doubts, ma? If you have any doubts, tell me. A die is, this is the first problem in geometric distribution. A die is tossed until 6 appears. This is the clue for you. Until 6 appears. That is, you keep on tossing the die till you get 6. Find the probability that it must be more than 5 times. That is, first 4 times it should be failure. Minimum 5 times. Okay. More than 5 times, not minimum, more than 5 times. That is, up to 5 it should be failure. Okay, explain what ma full? Yeah, this problem, this variance. Okay, variance sigma squared is E of x squared minus mu squared. Quickly I explain. E of x squared I have considered the first term, and here x squared I have added and subtracted x. Okay, then x into, split it, these two terms I have split it in the first one and the second one is x. Okay, then substitute x is equal to 1, you will get substitute x is equal to 2 and 3 and so on. Okay, then plus already we have sigma x into p of x is nothing but mu, that is the mean, that's why I have written 1 by p here, right? So and here common 2q is common, I have taken it outside. P is independent of x, that's why I have taken outside here. So p into 2q into expand this. Okay. Then e of x squared is 2pq into 1 minus q the whole power minus 3. This is formula. This is formula. This series formula. Okay. Plus 1 by p. So 2pq into 1 by 1 minus q the whole cube. And just simplify. This is nothing but e of x squared. And variance of x is e of x squared minus mu squared. Mu already we have found out. Mu is nothing but mean. Mean already we have found it to be 1 by p. That is why I have written 1 by p squared. Take LCM and this 2q I can have split it into 2. That is q plus q. So 1q I have written. 1q is combined with p, so that I will get 1. So q plus 1 minus 1. 1 will get cancelled. You will be getting q by p squared. Okay. Yes, so find the probability that it must be more than 5 terms. So minimum 5th term only you are getting success. Okay, and Varun, you can go through again. If you don't understand any step, please mention in the comment box, I'll answer. Okay, any term, any step, if you don't understand, feel free to post it. I will definitely respond. Okay, so now a die is tossed until 6 appears. Find the probability that it must be more than 5 times. So probability of getting 6, actually until 6. So our success is 6, right? So P is getting, probability of getting a 6. Small p is probability of getting a 6. Getting a 6. What is the probability of getting a 6 when you throw one die? What is the sample space you will have? 1, 2, 3, 4, 5 and 6, right? And probability is total is 1, 2, 3, 4, 5, 6. I want 6. So how many times you can, favorable cases is 1 and total number of cases is 6. So 1 by 6. Okay. So 1 by 6. Therefore our Q is 1 minus 1 by 6, that is 5 by 6. Getting a 6 is to be taken as success. Okay. And find the probability that it must be more than 5 times. So up to 5th term we are not getting. And what is our capital P of x is equal to x is q per x minus 1 and p. Okay. What is asked? Probability that x is greater than 5. X is greater than 5. Therefore you can write it as P of x is less than or equal to 5. Therefore 1 minus sigma x varies from 1 to 5 q per x minus 1 into p. Okay. So this is equal to 1 minus small p can be taken outside as I told you. 1 by 6 is correct ma. Yes, Akila. Yes. Yeah, 1 by 6 is correct. Therefore, q is equal to 5 by 6 is also correct. Yes, very good. So 1 minus p can be taken outside. So 1 plus q squared. When x is equal to 1, it will become 1. Q per 0. When x is equal to 2, it will become q plus q plus q per 4. Right? What is q value? 5 by 6. Just substitute 1 minus p into 1 plus 5 by 6 plus 5 by 6 the whole square. Substitute and tell me the value. Q is 1 minus P always, mom. Always remember this, P plus Q. For all these three discrete distributions, P plus Q is equal to 1. Okay. So when you know P, you just subtract it from 1, you will get Q. Or if Q is known, 1 minus Q will give P. Okay. Always remember this relation, P plus Q is equal to 1. Okay. Therefore, now P is 1 by 6, we know. That is 6 until 6 appears. Okay. So, getting a number 6 is our success. So, P is 1 by 6. So, Q is not getting 6. Meaning is not getting 6. Okay. So, 1 minus 1 by 6 which is 5 by 6. Understood? So, 5 by 6 the whole squared. So, 5 by 6 the whole cube. Substitute and tell me the value. Tell me the value. Anyone? Do it fast. One minus. Simplify this. Or even here you can put directly. P into. Even in sigma you can use in your calculator. I have taught you already how to use this sigma. In binomial I have explained how to use in the calculator sigma. So directly instead of writing all these things you can write x varies from 1 to 5. Q per x minus 1 into P also you can write. Whenever you want to take x, you have to use with alpha. That pink color one, you can use it with alpha. This I have explained in binomial. You can directly use your calculator to find out that. You can use sigma in your calculator. The whole power x you can use. X varies from 1 to 5. $3.588. No ma? No, always remember it is a probability no ma. So definitely it cannot be more than 1. So when you are getting a value more than 1, it means that you have made a mistake. That is a clue for you. Okay. It is a tips for you that it is a clue for you that you have made a mistake because the probability cannot be more than 1. You can get mean, variance and all values more than 1 you can get. Okay. When you are finding the probability, definitely it cannot be more than 1. One minus of Yes, Uma. 0.50256. I got 1 minus of 0.5981. 58. Yes, ma. 0.58 is almost correct. Uma, you have to check the values once again. Okay. Yeah. Dinesh, Varun, correct. 0.58 is right, ma. 0.588 is correct. Okay. Yeah, almost a nearby value. 0.588 might be correct. Yes, ma. Okay. 1 minus 0.5981 I got. This is the value. 0.4019. 0.16 is not correct. Kirtika, check the values once again. When you use the calculator, now be careful. 0.4019 is the answer actually. Nearest value is fine. 0.59 I got. Okay, you got 58. I don't know whether yours is correct or almost nearby is okay. Ma. Nearby values are right. 4018. Excellent. Raviteja, excellent. Yes. 0.4018. Actually 0.4019 I got. Yes. Very good. Very good. Directly I put in the calculator, I think. No? Yes. So 0.4019. Even Varun and Dinesh, I think you have found out this value, right? This value is 1 minus. It should be subtracted from 1. Don't forget that. Don't forget that. Yeah, 0.4019 is correct, Kirtika. You got it. Yes, ma. Yes. Okay. So next one more question I'll give you as a homework. Take this. In a large population of adults, 30% have received CPR training. This already we have done in our class. So it is available in the channel. You can go through. This is very, very important question. These kind of questions can be asked. CPR training, please note down these questions. The same, it is a continuation only. The people are in a large population of adults, 30% have received CPR training. That is in a village, some people are getting that CPR training. So if adults from this population are randomly selected, what is the probability that sixth person sampled is the first who has received the CPR training? Okay. So when you are selecting some people, you are getting the sixth person sampled is the first who has received the CPR training. That is why we have to use geometric. That is, before that people are, when you are taking one person, he is not trained. When you are selecting the second person is not trained person. Third person is not trained person. Sixth person is the trained. So first trained person. So first 5 persons are not trained persons. Okay. Like that. Then find out the probability that sixth person is the trained person. So probability that x is equal to 6. Greater than 6. The first person is 6. Okay. So first one is probability that sixth person means x is equal to 6 only. More than, not more than this and all. Okay. So small p is 30%. Right. So 0.3. 0.3. So q is 0.7. Q is 0.7. So p of x is equal to 6 you have to find out using the formula. And the second one is, what is the probability that the first person trained in CPR occurs on or before the third person, on or before the third person sampled. Okay, it may be the first person or, so P of x less than or equal to 3 is asked. P of 1 plus P of 2 plus P of 3. Okay, so you will be getting a substitute in that. Shiva Kumar asked something, ma'am, there is any chance to revision For first two chapters for. Please refresh, you will get. Any doubts? That's what any particular topic is required, you tell me. Post it in the comment box. Okay. Okay, everything is available. Already I have done. All the revision also is done. Enough number of revisions. This is again second time I am doing revision. Okay. Okay, okay, ma. If you want any particular topic, you let me know. And go through the topics available in the channel. Okay. For mid only I am telling, ma. Already 2 units I have completed. Only third unit normal distribution is left out. Okay. And all the best for your mid exams. Do well, all of you. Thank you so much for attending live. Please post whatever you have, whatever doubts you have.